Okay, in this video I'm going to cover measures of central tendency. What I'm going to cover here: mean, median, and mode of population and of the sample. Then determine the weighted mean of data set and the mean of the frequency distribution. Describe the shape of the distribution as symmetric, uniform, or skewed, and compare the mean and median for each. All right. Measures of central tendency. A value that represents a typical or central entry of data set. So remember what we were doing? We were cutting outliers, right? And keep the data that are centralized. So now once we've done it, now it's a time to analyze this centralized data. What measurements are important for centralized data? That's gonna be mean, median, and mode. Okay, let's explore all three of them. Mean. Everybody is familiar with the mean, that is average. You add all data, this is the sum, meaning summation, sigma, meaning summation. You add all elements and divide by amount of elements. So population mean, I would recommend to make a table. So, and write down this notation, like a table like this. This is population. This is sample. And here we are using mean. So for the population, we notate the population mean as a mu. We read as a mu. It's like reading mu long mu, something like that. Mu, and sample, it's gonna have x bar. Okay, so for the population mean, we are adding all elements of the population and we divide by amount of elements in the population. For the sample mean, which is x bar, we add all elements of the population of the sample and divide by amount of elements in the sample. Pay attention, n in this case is uppercase, here is lowercase, because population has one size of elements, sample has another size or amount of elements. Okay, so you won't get confused. If you see mu, that's talking about average of the population. If you see x bar, then you are talking about average of the sample. So here is example, finding a sample mean. The price in dollars for sample of the round trip flight from Chicago, Illinois to Cancun, Mexico are listed. What is the mean price of the flights? So here, because we have a sample, right, we are going to use the mean as an x bar, correct? So here it is, x bar is equal sum of all x's. We add all x's, divide by amount. So sum of all x's is equal, we add all these ticket prices, right? 1, 2, 3, 4, 5, 6, 7, and then divide by amount of tickets. Ticket price is 7, which approximately gets average price $527.90. Okay, $527.90. Now let's figure out the median. This is how we figure out, in a minute I will explain the difference between median and mean. When two measurements are very similar, they're always, you have to ask the question why. Why do exist two similar ones? That means there is a reason for that if two similar exist, because one is good in one case, another one is good in another case, and that's what I'm going to explain. So always asking question why it is the way it is. It's a very powerful question, and it will help you to find the answer. Once you understand why it is the way it is, you will never forget. Okay, so median. So to find median, it's also measure, it's also average, but how are figuring out the median? So first of all, we have to line up this data in the order. Let me see. Lining up in the order. See, we lined up in the order. Ascending order. That's the first condition for the median. Okay, then we are going to take the middle, the value of the middle position. Right here, see, 1, 2, 3. 1, 2, 3, middle position is 427. And this is going to be your median. You see? There we go. Median at the position. That 427. So based on median, the average is $427. Based on mean, it's $527.90. So big difference. Obviously, there is a big difference between median and mean. We will understand in a minute. I will explain. Okay, next, let's assume the $432 is no longer available. So we took off $432 ticket off because it's sold out. What do we have now? We have this price. We arrange in ascending order again. So in this case now we have even number. When we had all the odd number here, it was easy, right? You even numbers you separate, and middle position number value from middle position you take it as a median. Now when we have middle size, even amount of elements, how we're gonna deal? So first of all, again, we are going to arrange in the ascending order, right? And then we are taking two numbers in the middle, this one, and find the average of these two numbers, which is going to be, here it is, median 397 plus 427 divided by 2, average of middle two numbers. So it's going to be $412. Okay, now we are getting to the, before I go to the mode, I want to explain what is the difference between median and the mode, and why we are using both of them. So here is the case. Let's assume there is a neighborhood, and the houses in the neighborhood between $200,000 and $250,000. So the median is going to be somewhere, I don't know, between $200 and $250, right? Depends on which price is more there. All right, then turn out that neighborhood is the neighborhood where Donald Trump grew up. So he decided to come and build the house, so he dropped the $1 million worth house. What's going to happen? The average price is going to rise, right? Become $600,000 or $700,000. But will it be reflecting the true value of the average, true price of the average? Of course not, because only one house is going to be $1 million. The rest is going to be $200,000, $250,000. Now this outlier, extremely expensive house, $1 million, it's going to affect the mean, because when we calculate mean, we get involved every single element, every single price, which means $1 million also going to involve, and accordingly it will drag the value of mean higher. The different story is the median. If you take the median, it could care less for the median if you put $1 million worth house or $2 million worth house, because it's taking by position. It's not yet affecting by outlier. Let's see. if I had here, let's say, let's assume those are thousands, those are houses. If I add, or whatever flights, all right, I add here 1 million. Is it gonna affect? No, it's just gonna cost 427, right? 1, 2, 3. 1 second. Let me clean this so we can have conversation. Okay. So I added million. So then we have 3 here on this end and 3 on this end. So 427 will become, right, average, which means, as you can see, this $1 million worth, the value does not affect the average. So therefore, if you take the median, then $1 million worth house, it's not gonna affect the average price of the neighborhood. This is why when every single element is important, for example, let's say I'm going to confess now, I am by nature chocoholic. So every single when I see chocolate, I won't come down until I clean the entire chocolate off the table, and that's honest truth, I confess. So therefore, if I want to figure out how much chocolate I ate during the 1 month, I'm going to write down in 1 ounce I ate, and I'm going to write down, let's say, roughly saying half a pound of chocolate I ate within 1 day, right? And every single ounce I ate, it's gonna affect, right? I'm going to add all of them. I don't care how much it is, but I'm going to add and find the true mean average, right? So in this case, I would use it mean because every single element is important. But for the case of, if I would use median, that would be skewed information because median would take the average. Let's say 1 day I ate half a pound of chocolate, which would go as an outlier, the last number in the ascending line, because that will be the highest amount of chocolate I would eat, right? And the median would ignore and will take average, I don't know, 10 ounce or 8 ounce, and would measure as an average I eat per month 8 ounce, which is not gonna be the truth. So do we understand it? So in the cases when every value of every single element is important, we are using mean. In the cases like real estate, like I told you, when outlier is not going to be affected, excuse me, when outlier is not going to affect the average, we are using median, and we don't care to involve outliers in this case. Then we use median. Okay. I hope I made it clear when to use median, when to use the mean. Moving on. Mode. Mode is the highest frequency of the entry. Whichever number has the highest frequency, that one we call mode. Okay? It can be, if there are 2 numbers, both of them met in the database, let's say 4 times, then we will have bimodal. Let's see, we will go over. So in this case, finding the mode, which ticket price is repeat itself, has frequency, high frequency, 397, right? 1 and then 2, there is none anymore. So mode here is going to be 397, right? Because it occurs twice. Let's assume I would have another 432. Then it would be 397 and the $432 worth. So we would have 2 elements that repeat itself with the highest frequency. In that case, we would have bimodal mode. Okay, it would be bimodal. If we would have another one here, 388, then would be trimodal, because we would have 3 elements that repeat themselves. Okay, this is about mode. So mode is also identify kind of the measurement of central tendency. Okay, here is the question. Let's solve the question. Find the mode. They are questioning Democrats, Republican, other, and people did not respond. So 34 people responded positively about Democrats, let's say. 56 responded positively about Republicans. 21, other 9 did not respond. Now, because those are frequencies, which means 34 times was mentioned Democrats, 56 times was mentioned Republicans. So this is a mode, right? Each one of them is a mode. Which number is repeating the most? Of course, it's gonna be Republican, right? 56. So the mode in this case is gonna be 56. Why you don't consider bimodal? Because no other number repeat itself 56 times. The other numbers repeat less. So we call bimodal then two numbers repeat the same amount of times. Trimodal when three numbers repeat the same amount of times. Okay? All right. Here it is. 56 is going to be our mode. So now we're going to compare mean, median, and mode. Here is example. Comparing the mean, median, and mode. By the way, the slides I'm skipping, those I already explained, I already told you. That's why I'm not stopping at these slides. But if you want to read, you have your PowerPoint, open and read, or you can pause the video and read if you are interested. So, here is the case. Find the mean, median, and mode of the sample ages of the class shown in this table. Here it is. Those are ages in the class. Which measure of central tendency best describes a typical entry of the data set? So practically we are going to find out average, which value will describe the best average age of the class. Will it be mean? Will it be mode? Or will it be median? Let's see what we have. We have here outlier, right? 65. Somebody senior is has joined. 65 years old senior joined 24 years old student. So if I take mean, that's mean this 65 years old outlier is gonna influence, right? Affect the mean, and it's gonna drag the average age of the class into higher, which will not reflect the true average, correct? If I take mode, what will be mode here? I would say it's going to be 20, right? Because 1, 2, 3, 4, 5, 6. 6 times 20. 21, 1, 2, 3, 4. 22, 3, 23, 4, and 24, 2. So the highest frequency is 20. So if I take the average of the class is 20, it also will be skewed because we have there 21, we have there 22, we have there 23. So in this case, the only measurement of central tendency will show the true average will be median because we will line them up, and the 65 the age is not gonna affect, and we will get the true value of the average age of the class. Let's see. This is the X bar is mean, so it's adding up all the way. 65 get 23.8. Median, if you lined up, in descending order, and then 21 plus 22, those are middle two numbers, going to be, so it shows 21.5, which is, if you look, it's just about right, 21.5 years old. And the mode here is showing 20, which data is skewed. So practically the median is the one that will show the true average age of the class. Okay, that's how we analyze and figure out which one will describe the true mean. Okay, next. All right, it's not going. Let me see. No. So here it's practically showing everything I told you. Mean is this much, median is this much, and so on. We already analyzed. Moving to next one. Comparing all this mean, median, and mode by graphing, by building on histogram. So here we have, by the way, if our histogram is bell-shaped, okay, if we provide line, it is bell-shaped, right? In the case of when it's bell-shaped, then our mean, median, and mode are overlapping each other. Mean, median, mode. Overlapping each other and going right in the center. Different story when we have outlier. So it's gonna drag the mean, obviously. See, the mode is not gonna drag the change, because median is gonna stay right where it is, right in the middle, but the mean is gonna get dragged away from the where position of median is because of this outlier, 65 years old, right? And mode, it's showing not the true average, because mode is also skewed by the highest frequency of 20 years old age students. Therefore, when you look, median is the one, the best describe the average of the data set. Next, we are going to move to weighted mean. Weighted mean. Weighted mean is, we use this method to calculate your final grade, actually. Here you will learn how to calculate your final grade. We are going to consider the weight of every single grade, because as you know, let's say we said group activity, you have 5%, homework is 10%, test is 20%, so we need to consider this weight, and that's what we are going to learn. The mean of a data set whose entries have varying weights. So we are going to consider weights. So this is our formula for the weighted mean. Okay, so for the weighted mean, so we multiply every single x, which means in this case it's going to be the grade of our assignment, be it homework, be it group activity, be it test, we multiply by its own weight. So since weight is usually percentage, but we use decimal notation, as you know. So, and then we add up all this assignment, and then we divide by the sum of all weight. In our case, weight is usually, when we add them up, it ends up with 100. That's why, which is portion-wise will be 1. That's why we never put divided by 100. Okay, let's go over and see. Here is example. You are taking a class in which your grade is determined from the sources. 50% of your test mean, and then 15%, so 50% is a test, 15% is midterm, 20% is your final exam, 10% is your computer lab work, and 5% from your homework. I have to say it's quite diversified, this grade here. So your scores are 86 for test average, 96 for midterm, 82 for final exam, 98 computer lab, and 100 for homework. What is the weighted mean of your score? Meaning, what's the final grade of this student or whoever has this points, this score? Let's see. Here we placed in the table all this information. Test mean, remember, test mean was, test mean is 86, the weight is 5%, 50%, therefore this is the average. 86 is not one test, it's a test mean. Let's say if you took 3 tests and the average 86 point, all 3 tests, so this average you multiply by 0.5, which is 50% of the grade. Here it is, and you get in the final grade, the portion of your test is going to be 43. Next, midterm. There is one midterm only. Let's say student got 96. And the weight of the midterm is 15%, which is 0.15. So we are going to take 96, multiply by 0.15, and we get 14.4. So in the final grade, midterm makes 14.4 points. Accordingly, final exam, 82, 20% weight, so it's going to be 16.4. Lab is going to be 9.8. Homework is going to be 5, so a total going to be 88.6. Now let's find out how much is total weight here. 50, 15, 65, 85, 95, and 100, or portion wise is 1. This is why we don't divide by 100, because it doesn't do any difference. And the final grade of student is going to be 88.6. Oops, sorry, there is no A. It's going to be B. Okay. Here is a question to you. What if I want to know how much will be my average if I take into consideration, because I haven't done homework yet, so I want to know how much is my average based on test mean, midterm, final exam, and computer lab. So since homework is going to be 0.05, so instead of the 1, I'm going to divide. All right, let's see. Since it's 5 point, right? 88.6. If I subtract 5, I'm going to get 83.6, right? Less homework, because I don't want to involve homework. So I'm going to take x bar, it's going to be 83.6, and I'm going to divide by 0.95, not 1, because 5% is falling on homework. Because I'm eliminating homework, I want to find the average, my average grade without homework, because I'm considering, okay, well, homework is 5%. I'm not interested to do homework. Let me see, if I won't spend time on homework, how much will be my final grade? Is it legit question? Yeah, you bet. A lot of students consider that. They don't like spending time on homework. Therefore, for such students, here is calculation. So the homework, it's going to make 5 points in the final grade, final points. So we take final point, 88.6 minus 5. So 83.6, this is the average this is the total point without homework. And since at the bottom we add up every single weight, now here if I add up, since homework is 5%, so I'm going by elimination. 1 minus 0.05, I'm getting 95% or 0.95, and whatever point I will get, that will be my average. So let me see, I'm going to divide 83.6 divided by 0.95, that is going to give me 88. So some student would think, who is chasing only grade but not knowledge, would think, what on the earth, why on the earth I'm going to do homework, since without homework I'm getting 88, which is going to be same B, right? Okay, but the student, that's the student who is interested to get knowledge, and this way the grade will follow such student anyway. Good grade will follow because it's learning. Then we'll sit down and do entire homework, because that will help him to understand the topic much better. Okay, so this is about weighted mean. I hope I made myself clear. If you have any questions, please text me, ask me, and I can schedule day and time if it takes longer time to explain, so we can get on online on conference call, and I will explain. Okay, so moving to shape of distribution. All right, so I already talked to you approximately. When we have symmetric distribution, let's see, if I provide the line here, it's going to be perfect shape, bell-shaped, symmetric, right? In such case, like I already mentioned, mean, median, and mode are overlapping each other. Okay? So it doesn't matter which one you will take, you will get the average. Next. Uniform distribution, it's rectangular because that means all of them have same value, which is going to be 20. So it is also going to be symmetric. All right, and here we have because there is no mode here, all of them are 20. So the average is going to be median and mode, and they overlap each other again. All right. Next that is interesting is a skewed to the left, negatively skewed because it's skewed towards a smaller number, right? This is towards smaller number. There we go. So what do? Usually we cut, because this is when we ordering data, arranging, we cut the outlier, we don't need it. But in this case, in the case of skewed data, it's gonna affect our mean. So you can see the mean got stretched away a little bit, where the skewed data towards smaller numbers is, right? Median is the one who is standing still as an average, okay? And mode is also standing still. They both have to overlap each other, mean and mode. But the median and mode. But the mean is going to be skewed to the left. Now, in a case when we have data skewed towards bigger numbers, then the mean is going to be dragged towards bigger number, right? Here is the mean, it's dragged towards bigger number. So, and mean and mode are staying where they're supposed to be. Give me 1 minute, please. I will be right back. Okay. So it's a skewed data. So if we want to explore centralized data, what we're gonna do? We need to cut, right? Because we don't need those. Those are not happening often. Those are rare cases. What subject of our interest is always gonna be centralized data. All right. So we covered 2.3. We determined mean, median, mode of the population and sample. We determined we learned how to calculate weighted mean, and we learned the shape of distribution as symmetric uniform. All right, I guess I will record next 2.7.